morning to one and all. In last session we have seen insertion sort. Now the new sorting algorithms we are going to discuss, that is merge sort. These are the following table of content which we are going to discuss in a brief: introduction, the characteristics of merge sort, algorithm, example, time complexity, merge sort applications, and the advantage and disadvantage of merge sort. See, this is the standard definition we have described. The merge sort algorithm is an implementation of divide and conquer technique. Thus, it get completed in 3 steps. The first step is divide. In this step, the array list is divided itself recursively into sub array until the base case is reached. In second step, recursively solve. Here the sub array are sorted using recursion. In third case, combine this step, makes use of merge function to combine the sub array into final sorted array. With the help of 3 steps, we are able to sort an array. The concept which we have studied in insertion sort, here the merge sort is slightly different than the here 3 step is required. In first case we used to divide using recursion. In second case recursively solve, and the third is combine. After the divide of array into sub array and the sorting is to be done, and in last we have to combine all the sorted sub array and we have to make a single array, which the output will be the sub array into final sorted array. The merge sort is defined as a sorting algorithm that works by dividing an array into a smaller sub array. The sorting each sub array and then merging the sorting sub array back together to form a final sorted array. The merge sort is a recursive algorithm that continuously split the array into half until it cannot be further divided. That is, the array has only one element left. An array with one element is always sorted. Then the sorted sub array are merged into one sorted array. So, with the help of the 3 steps which we have seen in the first slide, the sorting the array will be sorted by using the concept of divide, recursive and merge. See, the merge sort is a popular sorting algorithm that follows divide and conquer paradigm. It works by repeatedly dividing the unsorted list into a smaller sublist, the sorting them and then merging them back together to obtain the final sorted list. It is known for the efficient stability and performance. It's predictable performance. The merge sort algorithms started by dividing the original list into 2 equal recursively until the sublist contain only the one element each. This is all already we have discussed in the previous slides. The step we are repeating this because these are the few standard definitions we have taken from the standard sources. See, the next the algorithm performs the merge phase where the merges of sorted sublist back together. To create the larger sorted and sublist, the components, the elements from the 2 sublist and select the smallest element each time and put in the final sorted list. In the merging sort process continues until all the sublist and merge into a single sorted list. One of the key advantage of merge sort is a stability. The stability means the relative order of elements with equal values maintained throughout the sorting process. This properly is important when sorting objects with multiple attributes or when preserving the original order of equal element is necessary. The characteristics of merge sort: First characteristic is external sorting algorithm. Here the sorting merge sort can be used when the data size is more than the RAM size. In such case, the whole data cannot come into a RAM at once, and the data is loaded into RAM in a small chunk, and the rest of the data resides in a secondary memory. And in the second non in place sorting algorithm, the merge sort is not an in place sorting technique, as in place as its space complexity is order of n. In place or space efficiently algorithms are those whose space complexity is not more than order of log n. Here the algorithm for merge sort, here the few steps are to be used when we are following the merge sort. These are the basic algorithm. By using these algorithms, we are going to write a pseudo code. By using this algorithm, we are going to write a program for a merge sort using C. This algorithm can be used to implement merge sort in any language. These are the basic steps which we need to follow when we are writing a pseudo code or when we are writing a program. The step first is the find the middle index of an array. To find the middle index of an array, we are using this formula: middle is equal to 1 plus last minus first by 2. With the help of this, middle index of array is to be find. In second step, divide the array into middle. In the third step, the calling merge sort for the first half of the array, that is merge sort bracket array and the first and middle. In step 4, the call merge sort for the second half of the array. The merge sort bracket array comma middle plus 1 comma last. This is how we are transferring the array and the values to the function. And step 5, merge the two sorted into a sorted array into a single sorted array. These are the five steps which is to be defined before which is to be explained before writing a pseudo code or a program for the merge sort. See, this is the pseudo code for merge sort. Here the procedure is defined where array it, meet and rt is variable is defined, where int L1 is equal to meet minus it plus 1. Here int L2 is equal to rt minus meet. Here the left L1 and right L2 variables are defined. In first phase, all the variables which are going to use in a merge sort is defined. Then the for loop, the first for loop we will run for I is equal to 0 to L1. Left I is equal to array it plus 1. Then end for loop. There will be two for loop. The first for first part and the second for second array. Then for j is equal to 0 to L2. Then write the whole array we are divided to two part, the left part and the right part. Then the first for loop is for left part and the second for loop is for right part. In first phase, we have seen the pseudo code. With the help of this pseudo code, we are going to sort an array, whatever algorithm we have discussed for the merge sort. In first phase, we are going to divide into half part, the left part and half part. Then this dividing of array is to be done until the each array is to be considered as a single element. Then after suppose an array is of 5 element, it is to be divided into two parts. The first part will consider of 2 element and the second part will consider of 3 element. Like this, the array will be divided, and in middle phase we will have an array, every element will be there, and we have to compare this array and we have to place into its appropriate places, and then in last we are going to merge the array and we will get the. So, this is the pseudo code for merge sort, and here is an example where we have taken the element of 4, that is 14, 7, 3 and 12. In first phase we are divided the array of 4 element into 2 array, that is 4 and 7, and the rightmost array is 3 and 12. Then again it is divided into sub array. Suppose in second phase array is the leftmost array is of 2 element, and in first phase the rightmost array is of 2 element. This in second phase the leftmost array is of 2 element and the rightmost array is of 2 element. Again they are divided into single element. Now we have 7, now we have 14. When the array is divided into single element, the comparison is to be done and sorting is to be performed, swapping is to be done. Then the 7 is placed into appropriate place, then 14 is swapped towards the right. Then in 3 and the same procedure is to be followed for 3 and 12. Here 3 and 12 are compared with each other, they are in appropriate place and we do not have to do anything. When we will see all the elements, we have created a single array for all the elements, and then the swapping is to be done and we have to find the appropriate place. And when we have to find the appropriate place, like 3 is in an appropriate place, 7 is in an appropriate place, 12 is in an appropriate place and 14 is in an appropriate place. When all elements are sorted, and then we have to start merging by following the same procedure. Now 3 and 7 will be merged together and 12 and 14 will be merged together. In the next step the 3 and 11 will be merged, and like that 3 and 7 is merged and 12 and 14 is merged with each other. In last phase the 3, 7, 12, 14 will be merged together and a single array will be displayed, and the sorting of merge algorithm is to be, the output of a sorting of merge algorithm will be displayed after the implementation. Here we have taken the another example of same 4 element. Why we are taking a few examples? Because there is a chance that here suppose we are taking even numbers of array. Here also we have taken 4 elements, previous example also we have taken 4 elements. What will happen if we take 5, 7 number of elements in a array? The number of steps will be more when we are defining the when we are performing the dividing the arrays into sub array. Here the 38, 27, 43 and 10 are the 4 elements. We have taken the example of 4 elements. It is divided into 2 parts. 38 and 27 are the leftmost array and 43 and 10 is a rightmost array. Again these sub arrays are to be divided into single element. Now 38 and 27 are the single element and 43 and 10 are divided into sub array. Now we have 4 array of one array consists of 38, one array consists of 27, another array consists of 43, another array consists of 10. Now swapping is to be done. The 27 is smaller than 38, then the swapping is comparison is done and swapping is to be done. The 27 will be placed in the leftmost side and 38 will be swapped towards the rightmost side. Now after swapping the array is to be merged, 27 and 38 is merged. Here the 10 and 43 is swapped with each other, and 10 and 43 will be 10 is in an appropriate place. Then we have to compare the element of both the sub array 27, 38 will be compared with 10 and 43. The comparison is to be done and we have to find the appropriate places for each element. The first is 10, 27, 38 and 43. These are the example of merge sort. Now again we will see one by one how the operation is performed when we have taken the example of 38, 27, 43, 10. What will happen in the first step? In first step is splitting the array into equal values, that is 38, 27, 43, 10. It is divided into two parts. The first part is consists of 38 and 27 and the second part consists of 43 and 10. In second step is splitting the sub array into equal values, that is 38, 27, 42 and 10. These are the two sub arrays we are having. One array consists of, the leftmost array consists of 2 elements, rightmost consists of 2 elements. This 2 element array is divided into split it into sub array. Now we have 4 array, each array consists of 1 element and the first element is called first element consists of 38, the first array consists of 38, second array consists of 27, the third array consists of 43 and the fourth element consists of 10. Now before merging, here we have divided, now we have to start merging. Before merging, we will see in the step 3. In step 3, this 38 and 27, before merging we have to compare these two elements with each other. The smallest passed will consider is transferred towards left. The 27 is lesser than 38, it is to be swapped and transferred towards left, and 38 is greater, it is to be transferred and swapped towards right. Then we have to perform a merging. After merging, 27, 38 will be the output of merge and 43 and 10 are to be merged with each other, and we have 2 array of 2 elements and both are to be compared with each other, and the comparison is to be done and each element is to be kept in a appropriate location or position. In step 4, we will see before merging of this 2 sub array, we have to perform the comparison and each element is to be kept in a appropriate place. The first smallest element will be the leftmost first element of the array, and the second smallest element will be in the second position, third smallest element that is called 38 will be in the third position, and the biggest element will be in the lastmost position. So, this is how we are performing the merge operation, and the array is to be sorted in the ascending order. See, this is another example. Here we have taken array of 6 element. In the after the first step, the array is divided into 2 sub array. Then each unsorted array is of 3 element. Then here the 3 elements are there in the leftmost sub array is of 3 element, rightmost array is of 3 element. Then in the second step, here whatever we have discussed in the previous, whatever we have studied and discussed in previous 2 examples, they are of even numbers. Here in first time we are receiving the array with of odd number after subdividing the array. Here you can see that in the second phase 2 sub arrays are of 3 elements. In the second phase, this 3 element is to be divided into 2 parts. The first array consists of 2 element and the second part consists of single element. This single element is, you have to check that single element is considered to be sorted, and at the time of merging we will perform the comparison and the merging. this 3 element we divided into 2 and 1 sub array. Here we have to subdivide the array till it is divided into single element. When we will see that all the element of array is divided into single position, then we have to perform the comparison between the array. Once we know that they are sorted, comparison is to be done. If the value is the rightmost value is smaller, then it is to be shifted towards right. Once it is shifted towards right, like that, by following the procedure and by following the algorithms, we have to start merging, and in last will find an array with of sorted. Here first time we have seen that the array is divided into 3 or even odd number like 3, 5, 7. If in an array if 3 elements are there, if in an array 5 numbers are there, then the number of step 1 or 2 number of step will be increase. This is the program for merge sort. Here we have include math.h library, 2 library we have included, 2 function we have developed. The merge 2 sub array, we have written a 2 function to merge a 2 array. The first sub array is array 1 to m, and the second sub array is m plus 1 to r. Here the 2 functions function we have created, that the merge int array r, int l, int m. This is the function which we have created for. Here the program which we have written for merge sort is divided into 3 parts. 2 functions we have written, and this 2 function is to be called into the main program, where this 2 program will be called and the output will be displayed in the console screen. In the this function will be called, and the value of array, value of l, int l, int m will be passed through the main program. This is the void merge. Void merge is a function which will return the value 0, and this function will receive the value from a main program. Here we have defined the integer r. We have defined the integer r, int I, j, k. 3 variables are defined, where r1, n1 and n2 is equal to m minus 1 plus 1, and int n2 is equal to r minus 1. Here these variables are defined and the values are initialized, and we have created a temporary array, and the copy the data to temporary array l and r are the 2 temporary array is we have created. This temporary array are important because at the time of swapping, at the time of comparison, at the time of creating an array, the information can be stored in n and r register. Here 2 for loops are there. Here 2 for loops are there. This for loop is for copying. The values are transferred to l and the values are transferred to r. L and r are nothing but a temporary register. Here we are following 2 for loop to transfer the value of subdivided array into L1 and Li and Rj. This is a function for merge the temporary arrays back to into a array. In previous function we have merged. We have seen that in that function we have transferred the information. We have transferred the information to in the previous function we have seen that the divided sub array is transferred to temporary variable, to temporary array L and R. Here I is initialized with 0, j is initialized with 0 and k is initialized with L, and j is less than while loop. We are using while loop where a is compared we are going to check whether the I is less than n1 and j is less than n2. Then with the help of if else, we are comparing, we are start merging the temporary array, and comparison is done and swapping is performed with the help of this function. This function is for copying the remaining elements of L. If there are many information, here we will check if I is less than n1, then the information of L1 is transferred to array K. The information is transferred and the remaining element of R is to be transferred to array K. Here again, once we have performed the sorting operation, the remaining element of the temporary variable are to be transferred to the main array. These are the two functions with the help of while loop we are transferring. If the element is left in the temporary array, the information is to be transferred to this. Here this is the main program. This is the main program where sub array are to be sorted. Here void merge sort int array int L int R. We have compared L with L. If L is less than R, this following the sort the first and the second values. Here when we divided, we have merge sort array 1 L comma M, merge sort array M plus 1 comma R, merge sort array 1 M R. Here we are calling, we have two functions which we have defined is for merge sort array comma 1 comma M. Here we are performing a sort first and the second values. Here we are calling the functions which we have created in the previous slide, and we are performing the merge sort. Here this function is for printing an array. After performing the void print array int a comma int size, here after sorting of array, after the sorting of array, the whole value of our array is to be printed, that is int I. For I is equal to 0, I is less than size, and with the help of this function, the sorted element of array is to be printed. Now this is the main program. This is the main program. With the help of this main program, we are calling the merge sort printed array and whatever function which we have created earlier. The first we have taken the array of 6 element, and the size of array is calculated and transferred to array size. First we have taken the array of 6 element, then the size of array is calculated, then we have printed the array, whatever we have in the array is initialized, we have printed the array, then we have performed the merging sort function. We have called the merge sort function which we have defined in the previous slide. Then the printing of sorted array is to be done. 2 times we are calling print function, because first we will print the unsorted array, and the second we will print the sorted array. In between the array is merge sort is called, where we will pass the array and the size of array we are going to pass, so that the main function of merge sort will receive the content of array, and the dividing of the arrays to be done, merging of sorting, comparison, sorting, and combining of the arrays to be done. Then print array, then we will print the sorted array and return 0. This is the main program, where whatever function we have defined earlier will be called and will be solved. See the time complexity analysis of merge sort. The time complexity of a merge sort is order of n log n. The merge sort is a recursive algorithm, and the time complexity can be expressed as the following recursive relation, that T n is equal to 2 T n by 2 plus order of n. The above recursion can be solved either using the recursion time method or master method. The application of merge sort. There are few applications where the merge sort is important. The first is the sorting large data set. The merge sort is a particularly well suited to sorting large data set due to granted worst case time complexity of order of n log n. The external sorting, the another application area is for external sorting. The merge sort is a commonly used for external sorting where the data is to be sorted is too large to fit into memory. The custom sorting, the merge sort can be adopted to handle the different input distribution such as partially sorted, nearly sorted and completed unsorted data, and it is also very useful in inverse count problem. The advantage of merge sort, the first advantage is stability. The merge sort is a stable sorting algorithm, which means it contains the relatively order to equal elements in the input array, and the granted worst case performance. The merge sort has a worst case time complexity of order of n log n, which means the performance well defined even on large data set. Parallelizable, the merge sort is a naturally parallelizable algorithm, which means it can be easily parallelized to take advantage of multiple processor and threads. When we are writing a program for parallel processing and distributed system, that time the merge sort can be easily adoptable. The space complexity, the merge sort requires additional memory to store the merged sub array during the sorting process, not in space. Merge sort is not in space sorting algorithm, which means it requires additional memory to store the data. It can be disadvantage in application where memory usage is concerned. Not always optimal for a small data set. For a small data set, merge sort has a higher time complexity than some other sorting algorithms such as insertion sort. This can result in slower performance with very small data sets. The merge sort is one of the most widely used algorithm in data structure, although it is not a space efficient algorithm. The time complexity is order of n log n, which is better than the most of the sorting algorithms. Whenever we have an input size larger than RAM size, we use merge sort. The merge sort is very well suited for large data set. In this session, we have studied what the merge sort, how it works, its application, drawback as well as implementation in various programming languages. Thank you very much for listening this session. Thank you very much.